Happy Friday, everyone. Thanks for joining us today. My name is Melissa Andrade, and I am the Marketing Director here at DATAMYTE. I'd like to thank you all for joining us today to watch our webinar on intelligent data collection. We plan to explore the challenges and opportunities of data collection on today's factory floor, data collection and its interdependence on other management processes. We'll learn about all the sources from which DATAMYTE can pull data, and how partnering with DATAMYTE can simplify your data collection and yield insights and reporting to support your productivity goals. We'll have a 35 to 40-minute presentation given by Chris Ackerman, one of our solution engineers here at DATAMYTE. This will be followed by 15 minutes or so of time for questions you may have. At that point, we will bring in our professional services team, including Vicki Peary, Diane Bunley, and Clay Honorud, to assist in sharing and answering questions. So the audio capability is turned off for you while joining us today. If you have specific questions, we ask that you utilize the GoToWebinar questions feature or request follow-up by one of our solution experts in the post e-survey so that we can address your specific requirements. This webinar is recorded and you will receive a link to it afterwards in case you need to leave early. At this time, I will turn it over to our presentation to Chris Ackerman.
Hi, everybody. Good afternoon and welcome, everyone. And so glad to have you all with us today, watching us from your office or from your home or wherever you might be at this Friday afternoon. Just want to cover our topic a little bit. We picked this topic for data integration because we've seen a big movement toward manufacturers planning to leverage technology as a key for their productivity concerns. So 43% said they will prioritize using one of the following methods, and we thought what we would do is just kind of give an overview and talk a little bit about data collection and how this information can be integrated with all the different sources that we might have and bringing all that information together. So I know it's kind of early in the webinar, but we're going to start off with a poll. And what we'd like to do is, for our first poll, just kind of get a feeling for what your top quality focused priorities are in your department. So we're going to turn this over to Melissa for polling, and just want to let you know you can choose more than one topic of these.
So I just want to get a sense of what are your top quality focused priorities in your department. You can choose more than one. That would be SPC, data collection, quality planning, APQP document control, calibration, gauge and tool management, or other.
And we'll give everybody a few minutes to fill that out. For those of you just joining us, our first webinar poll of the session.
All right, wrapping it up. And our results are 68% said SPC, 89% said data collection, quality planning, APQP document control 53%, calibration, gauge and tool management 26%, and 11% other. Thanks for participating.
Okay, thanks, Melissa. And I'm just going to bring up here, this is kind of the information that we used to drive our webinar today, was the information from Quality Magazine showing how important data collection is to the Quality Magazine readers. So we thank you for providing us with information that we can use going forward with this. Data collection, a big topic, and just from the poll that we did a few minutes ago, we see that's a big concern of many of our viewers. What I want to talk about a little bit is a few questions to ponder as we're looking at the big picture of data collection, data integration. Is more data better? It's just a question we want to throw out there. What data should be collected, and what is the scope of the data collection? So just a few questions we want to ponder. Let's go into a little bit more detail with those questions and just kind of explore them a little bit further. The common notion can sometimes be is if it can be collected, it should be collected. The problem is that you know, we have a couple of restrictions to that. If data is collected but never gets analyzed or reported, it's just kind of sitting somewhere and not doing us any good in that location. Data collection can be very expensive with 100% inspection. So operators, instruments, stations of collection points can be very costly. And then not just so much the collection point, but the background hardware that is also needed for data collection as well. So a number of items coming into play as to that first notion of, you know, collect everything. Let's take a look at what data should be collected. So as a company, which gauges do we have, or machines, any measuring devices that we might have available for being collected? How would that information get collected? How would we be, you know, doing that? And another question would be, how often is it getting collected? So number of items that we would take into account for, you know, what data should be collected. But let's look at some of the impact of the data. Do we have information that is critical to safety, maybe internal compliance to safety standards, critical to compliance for our customers? And then just the big picture quality or process improvement impact of the data. So we want to take a look at some of those areas of concern in terms of when we're deciding to collect the data, you know, what do we really need? And then we also want to take a look at the scope of the data collection. You know, we've got all these gauges, all these instruments of collection. What we want to do is identify which systems may need to be integrated and how can this information be shared back and forth. So we don't want to just collect it and store it. We also want to have a way to integrate that as well. So where are kind of the starting points? Well, maybe we have parts that we're generating or product that we're creating as part of our product definition and development. We may begin to have the first signs of clues as to what we should be collecting. For instance, on a product control plan, we might have a specification called out as maybe a critical characteristic that our customer would like to have some information for. That might be a way to capture information. We also might have, just as part of our process definition and development, we may have internally developed some layered process auditing and have a process auditing tracking chart, if you will, and have that as another field of information that would be collected. So again, different areas of information to be touched upon. So what we want to do at this webinar today is let's explore the complexities around that data collection. And what I want to do for just a second is kind of put a slide up here and you know, just take a look at the different characteristics that we have here. These are some of the different characteristics that you may be called upon to measure or have as a specification for your different products. Is this an overwhelming list? If you take a look at this, is this, as you look at this, do you see a number of characteristics that you and your department might be responsible for? Let's also take a look at the measurement methods, because sometimes that can cause a little bit of overwhelming. We've got multiple characteristics and multiple measurement methods. Sometimes that many-to-many relationship can create a number of challenges. So what we're going to do here is just kind of put a list of challenges together that we want to kind of address as we go forward. So let's take a look at one of the challenges. Might be too many outputs and interfaces. It's entirely possible that we could be overwhelmed because we have a lot of information that's out there, but maybe that information is not getting translated into a format that we could use. So that's something we'd want to take a look at. Also, too many what we call data silos. That's been kind of a buzzword lately. Data silos, databases, data storage units, if you will. So if we're think of it as that huge wall of filing cabinets back before the turn of the millennium, it's hard to find that information in all of the different filing cabinets. Where do we go and how do we find it when we need it? And then if we take that information and begin to create reports, that can also be overwhelming. We have a monthly report, a weekly report. We might have part-specific reports. We might have the layered process audit reports. All of that information can begin to sometimes be overwhelming. Same thing, a lack of traceability. This can sometimes get us a little overwhelming. Can we have a way of bringing information together so that we can see that, hey, on this particular day or this particular shift, or we know that a particular part was made? Do we have the ability to kind of trace that back to a time of production, a production line, a mold, for instance? Do we have that way of capturing the information so that the information is good information for us to use in terms of making corrections to the system? And then missed opportunities. This is one where, again, the overwhelming amount of data can result in some missed opportunities of what our goals are, objectives as a company, and creation of our parts or our products. So we're going to take a look at each of these challenges one at a time, and just kind of start with the outputs and the interfaces with shop floor data collection. There's a number of different outputs. So we go back to that slide a few minutes ago with all of our listing of characteristics. And all of those characteristics are being generated with a number of different types of collection methods. Again, that can sometimes get a little bit overwhelming because, again, we might not have the best way of always translating that information because we have those many interfaces that are being used for capturing the information or generating that information. So we again have this many to many identification of information that we have to address, and again, that can be overwhelming to just maybe come up with a starting point. Another set of challenges would be that same shop floor data collection, all of our different gauging information that's there on the floor, but where's that information then going? Not only do we have to translate it into the different reports, but we have to also figure out where that's going to be stored with those different data silos or data fields of information. So we want to be able to identify the information where it's coming from, but also where we're going to be storing that with the different data silos. Another challenge comes up as we've stored this information in the different data silos. Now, what are we going to do with it? Well, we don't want to just leave it sit there because that's not doing us any good. We want to be able to create this information on a number of reports, and sometimes the different reports won't always match up. So again, that many times many combination of input, storage, and reporting can then again get overwhelming because I don't know where the information is that I started with because it's not on the report that I expected it on. What we want to try to do is tie that information together better so that a report will actually give us good information going forward. And then another challenge that we talked about was the lack of traceability. So we have all these sets of data, and now can this information actually help us with a lot of our objectives? For instance, I've got a customer going back a few weeks ago. They had a storage area that was very close to their loading dock. And one thing they began to realize was that from the difference in the temperature from the loading dock was affecting the temperature in the storage area, which resulted in some faulty product at the loading step of their production line. So they were developing information from their temperature sensors. They could then track at what points in the year they would need to move the storage inventory to another location within the plant because it was not favorable to leave it near the storage dock in the colder temperatures of the winter. So that's just an example that I'm throwing out there where we have a data set of temperature and another data set of faulty material. How is that even happening? So this is how we can create a correlation of information, and the way that we would do that is create this ability to trace the information with incorporating traceability. So as we wrap it all together, we're looking at our unfulfilled quality goals, and this is an easy list to kind of look at because when it comes to this, we need the information to make some of these decisions or to address some of these decisions within our company. How are we getting the information that helps us to make the best decisions about the different quality goals that we might have here? So let's take a look at what we're doing as a company or as individuals within the company. And we have to remember that data collection in and of itself is not an island. What we're going to be having is a number of ability or opportunities to collect the data, but we always have to remember that strong interdependence with other management processes. So we always have to keep in mind that we're not the lone person collecting this data. This information is going to need to be disseminated throughout the company, but not just the reporting of it necessarily, maybe the input of it as well. So we have to take a look at the big picture of everything that we're tracking, capturing, storing, and reporting, and in the back of our minds, realize that this is not just maybe a one-person show taking care of that information. It has to be addressed as a company, as a department, as a division, if you will, and not have the independence of just one or two people or a single department being responsible for the dissemination of all of our data. So it helps if we have a roadmap. And where does this roadmap come from? One of the starting points is from quality planning. And I've got here a list of possible documents that are part of quality planning. And a lot of this information can help us with our kind of the starting point of where we need information to be gathered from control plans, from a process failure modes and effects analysis document. We can begin to comb through and see those areas of information that need to be captured, need to be reported, and need to be used for decision making. And just kind of as an additional step here, you know that some of our previous webinars have been dealing with quality planning, and one of which is the update to the process FMEAs and this step number 7, which is results documentation. in so many years we've had anecdotal information for using the occurrence value as part of our risk analysis. Now there is more of an emphasis on having some hardcore results for making those decisions with the occurrence values that are part of that step 5 risk analysis. So it's being standardized and implemented as part of the new process FMEAs, but this means that everyone can take advantage of that. We don't have to wait for an outside standard to be telling us that we need better information as we make decisions within our system. So I just want to give a brief overview of quality planning. I'm not going to spend much time on this. We can have an entirely additional webinar for this, but I just want to show you this time gap between the failure mode creation and the failure mode discovery. If we have better information, you can see that we can shorten the amount of time between those 2 points, and by minimizing that time, we're able to catch issues more at the point of the failure rather than farther along in our timeline. So just as kind of a starting point, the quality planning of the timeline of moving this information a little bit closer together, minimizing this time, is a perfect example of how having good information can help us with this particular process of with the quality planning. So at this point, what we'd like to do is I'm going to toss back to Melissa another poll, and we would like to capture from all of you, does your organization implement quality planning as a foundation for data collection? I'll toss this over to Melissa for the poll.
I've got the poll posted. Does your organization implement quality planning as a foundation for data collection? Just a yes or no. And give it another 3 seconds. And we find that we've got yes, 52%, and no, 48%.
Great. Okay, thank you everybody for responding to that. Great information for us to have, and we appreciate your response to that as well. So what I want to do now is move on to maybe the next step as we create a plan to put together our information and data collection. I want to talk briefly, I've talked a little bit here about quality planning. I want to also talk about gauge and tool management because this comes into play a little bit to make sure that that we are following standards that we would use for the different gauges and tools that we're using. So there are standards out there called measurement systems analysis to make sure that that we have tools that can be measured correctly and give us very good information. And again, the backbone of all this data collection is that we do have information for which we can make decisions that is of high quality. So that includes some of our allocation methods, maintenance programs, how often is a particular gauge sent for calibration? Do we have backup plans for if a particular gauge is faulty? Can we swap them out? Do we have documentation of those gauges that they've been calibrated, that they've had? For instance, if you've heard the term gauge R&R, do we have that? Do we have that information kept as part of our information source? So what I'm going to do here for our next step is we're going to make two assumptions. And those assumptions are going to be that we have a quality plan and we have gauge and tool management, and we're following MSA. So we have a plan, we have the tools. The next question that we need to then address is how will we collect the data? And this is another important question that we have to then address. And the way to address this would be with the creation of what we call an inspection plan and inspection planning. So what we're going to do is actually engineer a series of steps for the planning of these inspections. So what characteristics do we wish to measure? How often are we going to collect? Because we talked earlier about 100% inspection can get very expensive. So we need to have a plan for picking and choosing, essentially, when we do this. Now, here's a key point that we want to pass along is that you want to design your plan based on what you want to see from the data. And you know, this kind of sounds like we're starting at the end of the movie and coming backwards. But think about it, the information that's coming out on the report, the information that we want to disseminate to customers, to internal documentation, we want to have that as the endpoint and perhaps work backwards from that in terms of what we need to capture, collect, measure. And the key here is that we want to be proactive versus reactive. So let's not wait until we have a warranty issue to begin measuring for faulty conditions. That is too far past the timeline. We want to anticipate as much as possible from some of these outputs, information that can be used for as good information. So again, to be proactive versus reactive as much as possible. And then we also want to bring into play additional inspection plans considerations for which, for instance, the best tools to take the measurements. Now, the example that I'm going to use here is that so many times people will say, for instance, visual inspection. Okay, are the operators responsible for making a decision in terms of a faulty part? Do we have a better tool to take some of these measurements than relying on the operator's best estimates? Maybe we don't always necessarily have to do 100% inspection, but we would want to have the operators trained as visual inspectors, but then still have a backup in place as well. Do we have a gap and flush system that is with maybe perhaps a laser gauge that can help to take those measurements? Again, the best tools to take those measurements, do we have them available? How are those measurements being captured? Are we using a system that's going to grab the information, store it in a database, or are we perhaps walking around with a clipboard and a pencil? Is that always the best way to to be capturing that information? Keyboard entry versus an output from a gauge directly into the data system can result into issues where if I'm typing in a number, I don't necessarily have the information correctly entered that I'm taking from my clipboard. So this is something else that we'll have to address as well. Where are the measurements being captured? Do we have the flexibility or the ability to do an in-process inspection as well as the final inspection? Do we have the ability to capture it at two different points in the process and then maybe perhaps compare that information? Here's another thing that I know came up with one of my customers was that they had a quality lab where they would send a random number of parts throughout the throughout the production line, but there wasn't always a timely response from the quality lab. So information was being gleaned from the parts being sent to the quality lab, but not reported back in a timely fashion. So this would be an example of, in addition to in process versus final inspection, are there occasions where we are sending a sample of parts into a laboratory environment for additional testing? How fast is that information being responded to? Also important. And then where are the measurements being recorded and stored? If we start off with the pencil and paper, are we storing that information in a filing cabinet? Are we taking that information and entering it, maybe keyboard entry? Are we able to take more of our measurements with electronic means versus paper? Again, the kind of information that we want to bring together and roll together if at all possible. So what we want to help you do is to leverage DATAMYTE's data collection experts. And through a couple of steps, we would be happy to partner with you in addressing some of the different challenges. For instance, one of the steps that our data collection experts can help you with is to help you identify all of the data that you might have available. So back on some of those previous slides where we have those huge lists of characteristics and maybe a large number of the different interfaces coming from those different measuring devices. What we want to help you do is look for all the opportunities that you might have for product characteristics, process characteristics, a number of types of opportunities to identify different data points throughout your part and process production. And then we also want to help you be able to store that information, that data, in one database. We have plans, opportunities for you to bring that information together. Maybe there has to be an interface developed for some of those gauges. Let them get them all essentially talking the same language, and then have all that information stored into the database. We want to be able to help you with the management of that database creation or the data silos, if you will, bringing the data silos together so that information can be distributed between the different data silos. We have data services that can talk to multiple databases and share that information with handshaking if that in fact needs to be done. And then another area is we want to be able to help you generate the reports for analysis. So after we've identified where we're going to collect it and then where we're going to store this information, let's take an opportunity to make that information valuable for access and information to help us actually with our production. So let's turn this data into valuable information, and then have this collection of data and the storage of the data and the reporting of the data all be a continuous system that can be leveraged to help make better decisions from the information that we are gathering. So I want to take an opportunity here to just kind of give you this big picture of everything that we at DATAMYTE can assist you with in terms of data collection. I know that if you're looking at this picture, a lot of this can be overwhelming. Well, you may have some of these at your plant. You may not even know that you have this information available. And this is again where we at DATAMYTE can help you with some of this information. Glean this information into your different the different interfaces that you see there, and again get all of the information to speak the same language if we need to. Bring all of that information together together and put it into a single database or partition database if we need to for different divisions, different locations, different production lines. All of that information can be captured and then categorized and have that traceability brought together within the database. And we want to take at this time an opportunity to, if we look at this big picture here of all the possible types of gauging opportunities that we may have, or data collection points, what we want to do for our last poll is just kind of get a feel from all of you, measurement systems in place from which you are not currently pulling data. And I'll toss this over to Melissa with just a reminder that you can check all that apply. And if none, then go ahead and leave blank in this condition.
All right, I've launched the poll. Do you have any measurement systems in place from which you are not currently pulling data? Just a few categories there.
And we'll give everybody a few more minutes. Oh, sorry, go ahead, yep.
And I'm going to close the poll and share my results. Do you have any measurement systems in place? We have 39% needing to pull data from PLCs, 28% from digital gauges, 33% from file output CMM, 28% serial output from scales and other measurement devices, and 39% from other databases. Thanks for participating in the poll.
Okay, thanks, Melissa. And jumping back to what we want to talk about a little bit more is this big picture of shop floor data collection components. So we've talked about all the different types of gauges that might be used, but what we want to do is kind of give you more of the picture of what we're able to help you with your DATAMYTE solution. So for instance, just all by itself, we identify a characteristic to measure, kind of with that roadmap we talked about earlier. Maybe this characteristic comes from our control plan for our particular parts, or maybe this characteristic is from our process audit. Either way, we know that we have something that we need to measure. We've identified it as a characteristic or a specification. The next step is we would decide the data collection use case. For instance, do we have a number of stations throughout our facility where we would have the ability to collect this information? Would it be a fixed station that would be operator attended, or lights out, which means automatic data collection, no operators for the lights out option? Is it a mobile data collection station with perhaps a laptop computer that is going to help assist with storing the data and capturing that data? Even the technology now with tablets and cell phones now can create a data collection station. Yes, a cell phone can in fact be a data collection point, as well as our 600 data collector, portable data collector, mobile data collector. So that might be one of the first areas that we would look at for a particular characteristic or a number of characteristics to measure. Another area that we'd want to take a look at is that inspection plan, putting together the plan for when we're going to inspect that, where we're going to do it. And this is where we then incorporate using a particular gauge. That particular gauge might be wired and connected right to the PC or right to an interface, or we have a number of gauges now that can be, the information can be captured through Bluetooth connections, wireless, Wi-Fi, a number of different ways that this information is, again, going back to the same set of characteristics. A number of options for the same characteristics are entirely possible. Then we also want to store that data, and we've talked about this a couple of times with the database, storing it, but how do we want to capture that database and then store it? We want to move away from that file cabinet. We want to get this information into a language that can be stored in a database, and then the information for all these different characteristics will come in, and based on our inspection plan and the gauges that we're using, we now have some good information stored in a database, and also information that might be shared from another database. We might be able to share that information, bringing it into the DATAMyte database. And then we also have a couple of components here that we want to talk about as well, is the ability to have an alert condition. So the information comes into the database. We might have a non-conformity. What's going to happen with that information just sitting in the database? Nothing. So what we want to do is perhaps trigger an alert. Maybe this alert comes from within the database, and it allows somebody to take action, quarantine the part, quarantine a grouping of parts, a number of conditions that can result from having an alert condition for a nonconformity. And then we also want to have the ability to escalate these nonconforming events. Bring this information to a team. So this is a little bit different than just generating a report. What we're doing here is we're saying, hey, we have an out of specification condition. An alert was generated. Maybe the alert has detected that has not been acted upon. So now this information can be escalated to an additional team member or another level of management, so that information can be addressed and a decision can be made for this alert condition if we need to. And then ultimately we get to this reporting point, and at this point we might have a report that's generated on by shift or by week, or management wishes to take a look at monthly reports. This can all be generated with a data collection component of the reporting component. So we can help you sit down and design this plan, starting from that characteristics measure. What kind of station are we going to have? What kind of a plan for inspection will we have? What gauges will be involved with that inspection plan? And then store that information in a database, maybe share that information or get information from other databases that needs to be shared, bring that information into the DATAMyte database, and then from that point moving out, disseminating the information into either an immediate alert condition, a timeline of escalation, and then also a report to be generated with that information that would kind of take us to the end of the 7 steps here for this data collection component. So we would love to be able to help you with all of that, all of those steps of information. If in fact you need to bring this into play. One thing that we like to stress, of course, is that this is a continuous process. So the information that we're generating is allowing us to make better decisions as we continue with our manufacturing process, our creation of our parts. As we bring this information together, we realize that it's going to be dynamic. We'll have conditions that will interact with this collection of data based on needs or budget or new technologies coming into play. And so we look to partner with you continuously, not just kind of a one and done, As more integration of data may be required, we would like to begin and continue and partner with you with this continuous process of data collection integration. So I want to take you to kind of the DATAMYTE approach to quality, and this is why one of our polling questions was about quality planning. You can see that this is one of the first steps in this continuous circle is to have that plan in place, and maybe it's a quality planning coming from advanced product quality planning, or it also might be the planning that's involved with your gauge and tool management, and that's the circle, the part of the circle that then leads into that data collection. So it's always important for us to have that information before we get to data collection. And that's yet another step that we want to assist you with and partner with. So we're not just there to sell you this data collection solution. We think it's important for us to be there before those steps and help you identify the information that we will be addressing, what information needs to be collected. And then you can see that we move into the analyze quadrant. We've collected some good information, put it into a database, and now we're going to analyze that information, and then ultimately that will lead to the improved step, custom reporting, enterprise, dashboard alerts, those notifications, and then ultimately that will be a process improvement that we take back around to the planning cycle and continuous improvement. Here's another graphic that I want to show you that where we've taken that DATAMYTE quality circle, kind of put that right in the center, and you can see that all of the different fields of information that can be brought into the DATAMYTE quality loop or continuous improvement circle. We've all got the different quality systems tying together to the circle, and also with the DATAMYTE database, and like I mentioned earlier, some of those third-party data silos might also need to be brought into kind of a handshake condition if you need to bring that information as well, to bring all of it together in that continuous improvement cycle with what we have here for a quality system. So again, we would love to help you make sure that your quality system is effective, and help partner with you with a lot of these decisions going forward. At this time, we'd like to open up the webinar for questions, and hopefully those of you who had questions as we've moved along have been sending those in. I will turn over to the team now to see if we have any questions.
Thank you, Chris. That was a wonderful presentation. I learned a lot. This is Vicki Peary. I'm one of the solutions engineers here at DATAMYTE, and many of our customers have been asking variations of this same question. Does Datametrics have options for automatic data collection?
This is Diane Bundley. I'm another solutions engineer, and I can answer that. I think Chris's presentation really pointed out a lot of, you saw a lot of those things that we can collect data from, but, whether it's that you have digital gauges, micrometers, calipers, dial indicators, maybe they don't have cables and you're writing it down on paper, but yes, you can connect either wired or wirelessly. We also have, various serial devices that we can connect to, scale being, a good example. But, any kind of a serial output, serial CMMs, CMMs can be either serial or send out a text file. So, all sorts of serial outputs, that plug in. Now we use USB. So we can connect, just ask us if you've got a device and you're not sure about. Anything with a text file output, like I say, a CMM, or there are lots of devices that send out text files. then we can also, collect data from PLCs, from other database. Maybe you have another SQL database that you want to collect data from. And, we also, when the question is about automatic data collection. So that could be lights out, meaning, I have a device that the CMM is just sending out a bunch of data and I want to collect it without an operator around. We have a driver for that. Same thing with various databases. Set that up so that it just, as soon as the data comes in, it goes to the DATAMetrics database. So
thank
I'm
you,
sure
Diane.
I missed something, but yeah.
Can I ask another question? This has come up. What is OPC?
Okay, there was a name for it that an old name, but now it's called Open Platform Communications. That's what OPC stands for. And it's the communication of real-time plant data between control devices from like various machines, manufacturers. So your PLCs, which is what, programmable logic controllers. So say you have a PLC and you want to grab data from that. What you would need is some kind of an OPC server. Some examples would be like Kepware or Wonderware. And that server then would feed data to DATAMetrics. We have a driver that grabs data from the OPC server. And there's some enhanced security now. There's a thing called Universal Architecture, UA. And so, our driver incorporates that. So it can work with virtually any OPC server. Okay.
Any other questions?
Oh, I'm sorry. I have a question.
Okay.
Can DATAMetrics collect data from USB devices?
Well, this is Vicki, again, solutions engineer, and I love that question. Yes, we can. And we can either do this from a virtual serial port through a USB connection, or it could just be a keyboard entry. It depends on how the gauge is configured.
Okay. Another question. Does DATAMetrics allow you to collect torque data?
I can take that one.
Okay.
This is Chris again. And actually, I am going to use one of these fancy tools and highlight right here on the slide our torque audit collection. So you can, our collector, that's our DATAMYTE 600 with a torque wrench. And we have made a number of improvements, technological improvements. So the wrenches are now wireless. The operators will walk around with a mobile device, this collector, and then be able to take torque readings with the wrenches and have that information fed into the collector, and then Wi-Fi connection to the database, and have immediate reporting from that information. So good question. Thank you for asking.
There's also a new thing too with the fixed station. DC Advanced now can collect torque data from wired or wireless torque wrenches.
Well, thank you both. Here's another question. This is Vicki, by the way. Do you support math formulas and Boolean formulas in data collection?
I'll take that. Yes. Math formulas like, typical Excel formulas. And also it can be, we can use Boolean formulas, if then type of formulas. So for instance, let's say you have a device that sends out data and it doesn't send out data all the time. Sometimes it skips things. And so you can say, okay, if it's true that there's a value there, grab it and take it. If there's nothing there, then put a null value. And there are very many uses for that Boolean formula. So that's one that people may not be aware of. Vicki.
Yes.
And data metrics track data by process as well as by machine?
Well, actually, Diane, that's a wonderful question. We have Datametrics has a component that we call process, and that is used to create a part and modify the part, such as a machine name, for example, a drill press number 1, or an action that a machine performs, like drilling, mixing, molding. In DC Pro, we go a step beyond, and we can support multi-position data collection, so like with multi-mold or multi-spindle, and using process. We can track measurements for each process. We can even, in the multi-position, block processes that are temporarily unavailable without changing the inspection plan. And what this gives me is the ability not only to see how different machines are performing, but also to calculate capability down to the machine or process level.
Great.
We just got a new question here. My facility collects and analyzes data, but we have a manual process, and that leads to a big delay from collections to reporting. Can technology reduce the amount of time between collection and when I can see the data on a report?
Definitely. Measurements captured either directly from a gauge or using keyboard entry are stored in the Datametrics database, and they're available for real-time data analysis. So that's one thing. But moreover, we have tools that can alert the team when you have a nonconformity, like an alarm or something, as well as real-time dashboard monitoring that at a glance brings all the collected data to immediate attention to the team.
And another just raised question, can we connect data from a previous measurement or raw materials to an in-process measurement on a later date? I think we have the subgroup driver for that, don't we, Diane?
Let's see, previous measurement. Yes, we do have a driver for that. Let me give you an example. Let's say that you have to take tear weight measurements once a shift, and you want that, you take a number of packages and get an average tear weight measurement. You can then have that automatically subtract that from the weights that are taken, and that really eliminates a lot of the problems that people have with, forgetting to take the tear measurements or forgetting to update them and things like that. Are there any other questions?
Diane, we do have other questions, but to respect people's time, I think we're going to need to stop at this point and turn it back over to Melissa.
Thank you very much to the team for answering some of your questions. I know I've seen some of the questions come in. If you have kind of more specific, detailed questions, making note of those, and we'll have a team member reach out directly to you to follow up. You'll also receive an e-survey that'll come after the webinar with access to the recording and a brief survey. If you have any follow-ups that you would like from our end, please note them there, and we will follow up with you. And I hope you all have a great weekend, and I wish you a healthy and safe time this weekend. Thanks so much to the team.
Thank you.
Bye now.